Hey guys, Kevin Stumpf here with URETEK USA, and today I want to go out west to the San Francisco International Airport and tell you about some recently completed work we did. Now if you look at this picture, you can see we're working nights. Obviously, on a major runway at an airport like San Francisco International, we want to minimize the downtime. So working at nights is the logical choice for that. Now you can also see that we brought in 4 rigs here. Instead of normally deploying 1, we brought in 4 to increase production, to minimize the number of times we have to shut the runway down at night. So this kind of shows scale, and it shows how we accommodate to the needs of the customer as well. So I'm going to switch over real quick and show you an aerial view of this. You can see this is the runway with the yellow line on it. It's 11,381 roughly feet long. So we're talking a big area, obviously one of 4 major runways. Now here's the situation. They did analysis on it and indicated that they needed to extend the life of the runway. And there's a couple ways to do that. One way in particular is full depth reclamation. They call that rip and replace. Basically dig it out or rebuild it all. Now obviously there's a lot of downtime with that, a lot of cost involved. So they looked for some alternatives. One would be for us to come in and inject in between their sub base and their cement treated base in order to stabilize the foundation soils basically. And then they'd come in and do a mill and overlay to create a new wearing course for the airplanes to land on and take off on. So we ended up coming in and doing that. I'm going to switch back here. We'll scroll down a bit. So when we got on site, we started doing dynamic cone penetrometer testing. And if you're not familiar with the DCP testing, check out my blog article on it. I have a short video explaining it. Basically, it's a geotech investigation type of test. And it indicated weakened soils, starting at about 8 feet, and high water infiltration we noticed at that level as well. So we ended up treating at minus 10 feet and then also at just below the CTB, cement treated base. Now, the cool thing about this project is we hired Dynatest Consulting to perform heavyweight deflectometer testing. This is basically they drop a heavy weight and test for deflection at the surface. And what it's going to do, they're going to do calculations that indicate the strength of the subgrade as well as the strength at the CTB layer. So what they came up with, which is kind of interesting, is in the control areas from the pre-test to the post-test, it actually got worse. It dropped 18% at the subgrade and 35% at the CTB. The reason this happened is they received a lot of rainfall in that time period, and actually the subgrade weakened with this test over that time. Now what's interesting is the areas we treated actually improved. So we overcame the extensive rainfall degradation and actually improved the strength of the subgrade and strength of the CTB. Subgrade up 15.7%, CTB up 21.15%. So some tangible data that shows that the URETEK deep injection process actually increases bearing capacity of those subgrade soils. Also, to wrap it up, they did another analysis, and actually that new analysis indicated the areas that were treated with the polymer injections increased the remaining life to over 20 years. So that's good as well. Anyway, guys, there's a lot to digest here. I recommend you download the file and actually read through it and kind of work it. If you have any questions, give me a call. Appreciate it. Thanks, guys, for watching these videos. We'll see ya.